Cameron. Cameron, the product manager on the Go team. How is that for you?
Oh, it's great. I joined Google 2 years ago, and I joined the Go team straight away, but it's only recently that I've become the product lead, and it's such an honor. What an interesting, awesome community and opportunity to sort of be able to inherit and try to build on. I'm very excited about everything, and I think it's such a great team. Like, even everybody at Google is really great, but within the Go team, I think they're even better. So that's been awesome.
Well, just on behalf of the community, we want to thank you. The work you're doing is great. It's so important, and I love that Go has a product manager. I think that is such an interesting thing in its own right. And also, you play the guitar, don't you?
That's right. Yeah.
Ooh, what's your favorite chord?
My favorite chord?
Yeah.
I would say A minor.
A minor. Ooh, yeah, that's a moody one, that. Says a lot about you, Cameron.
It does, right?
Yeah, doesn't it? Okay, well, without any further ado, please put your hands together one last time, and for our final speaker, give it up for Cameron, everybody!
All right, thank you, everyone. Last talk of the day. I appreciate everyone being here, looking forward to sort of wrapping this up strong. So, as I said, I'm a product manager for the Go team. I've been at Google for 2 years. I recently took over for Steve Francia, who I'm assuming many of you probably know. Steve has some huge shoes to fill, so I have the sort of unenviable task of following his act. And to sort of maximize my contribution, I thought I'd go down the path of thinking, what was Go's product evolution? How did Go get here? What did the community do? What did the team do? What did Steve do? What are the pivots we made along the way? So I'm here to talk about what I learned, and I call this process, this whole thing that I discovered, how Go became its best self. Let's see. All right, so judging by the fact that you're all at a GopherCon, I imagine that most of you have heard of Rob Pike's famous 45-minute C++ build that prompted he and Robert to think up some ideas that eventually became Go. I like to summarize the origins of that frustration with this famous quote by Urs Holtz, who's employee number 8 at Google, where he says, "At scale, everything breaks." And here's that quote in context. At scale, everything breaks, no matter what you do, and you have to deal reasonably cleanly with that. Urs said this in 2011 on the heels of a period when Google was transforming from a reasonably large startup to a behemoth, or as we like to think of Google, the world's largest startup. And if we go back early enough, this is all Google used to be. In 1998, this index had 26 million pages. In 2000, it reached 1 billion pages, and by 2008, a few years before Urs's comment, it had reached 1 trillion pages. And it used to be these two people, a little before Urs joined, and I guess this is sort of what their office looked like. But in the period between when it was founded and when Urs made that comment about scale in 2011, or when Go 1 was released in 2012, it grew to be a lot more people, Google did. This slide shows Google's headcount between its IPO in 2003, when it had a little over 1,600 employees, and up to 2012, when it had over 60,000. So this meant a lot more people writing a lot more code, and ensuring that all this complexity worked well together, that it didn't break, that it was readable, all of that. It carried a lot of overhead. It became more difficult, which meant that developer velocity suffered, resilience suffered. And since Google's business is all about scale, this problem was only going to get worse. And this is where Go was born. Google was struggling with its scale, especially internally. The complexity of a massive code base with so many programmers working on the same projects in Java and C++ led to brittle code, low readability, diminished developer velocity and productivity. So in that famous story of Go's origins, that 45-minute build, Rob Pike thought, is the solution to all of this more features? Did the C++ committee really believe that what was wrong with C++ was that it didn't have enough features? Surely it would be better to simply simplify the language than to add to it. And by the way, as a quick note, a quick aside, and primarily because I was curious, I figured at least some of you might be as well. This is what that earlier chart of Google's headcount looks like after 2012. In 2012, it was at 50,000 employees, and last year it was 3 times that. So that scale persists. Google continues to scale, and it continues to use Go extensively to help with that. So stepping back and looking at the bigger history of the project, Go has had a few distinct phases in its evolution. We spent 5 years between 2007 and 2012 building Go, open sourcing it, refining it. And then in 2012, we shifted to using Go, putting it in production primarily at Google, but also beyond. And 5 years after that, we decided it was time to leverage all this experience that we'd accumulated over the last several years to improve the language again. And for a long time, this improvement project was called Go 2. Eventually, it was released as Go 1.18 this past March, and it contains a lot of really significant changes, as we've all talked about. Most of all generics, of course, but also fuzzing and workspace mode and all of that. And that's where we are today. Go 1.19 will be out next month with lots of refinements to what we released in Go 1.18. And at the end of the presentation, I'll touch on a few things that we're looking forward to in future releases as well. All right, with all of that as prologue, let's talk about the most significant things we had to do in order to take Go from a mostly internal Google tool in 2012 to the quite successful, fast-moving, fast-growing language it is today. The first is we had to embrace the community. So from the outset, Go was really well received, especially by the open source community. There are these really notable projects on this slide, like Docker and Kubernetes. They're all written in Go. Really, it's fun to think about how the whole cloud is, this next big frontier in computing is mostly written in Go. But as recently as 6 or 8 years ago, we didn't really know very much about how Go was used outside Google. Although Go was open source, the team was overwhelmingly focused on internal use. That is to say that internal projects at Google were using Go and deriving tremendous value from it, but Google's use is quite different from the rest of the world's. And if you want a language to succeed, you need it to be more than just Google. If you continue down that path of only optimizing for internal use cases, you risk getting a tech island. And a tech island will bite you with overhead, with employee dissatisfaction, just a disconnect from the broader development community. So this slide is from the first annual Go survey, which we held in 2016. So apparently, CLIs were the #1 use case, but that was a complete shock to the team. At this point, we didn't know that Go would be good at CLIs. The survey comes out, and we find that it's the #1 use case, and we're totally taken by surprise. Going in, we thought Go was just good for RPC services because we were using it that way. We assumed everyone else was using it that way. We didn't know that people used it for web apps either, the #3 use case here. But that's less of a shock because that's closer to RPC services. And all this revealed this sort of amazing fact. Even though we were the ones who were defining the future of Go, or we thought we were, maybe we weren't. Maybe the community was just as important. And if you look at Go's main use cases today, things like CLIs and web frameworks, Google didn't create them, the community did. Even Windows support, that originates from external contributors. So the truth was that the community had had one hand on the wheel the whole time. Because our sites were entirely internal, we didn't really see it. And this is where we learned that we had to embrace the outside. Another thing we learned in this first survey was that while the community was confident in Go leadership, they agreed much less on whether leadership understood their needs. And they agreed even less that they felt comfortable approaching project leadership with questions and feedback. So it's an interesting relationship with the community, a community we didn't really know well, a community that didn't know us well, and all along we're both steering the direction of this project together. Embracing this community and steering it in the collaborative manner that we do now, it all seems obvious in hindsight. But before this survey in 2016, it was really quite controversial. Google simply didn't see the value of Go's growth, really, outside of Google. And that was reflected in how we led it and how the community saw us lead it. Yes, it was open source. Google knew that open sourcing a language was critical, even to internal adoption. But it was hard to appreciate that there's actually a community that you need to embrace as well. It was hard to appreciate that there are contributors out there who don't get paid, but also just find it motivating enough to contribute to a meaningful project. And I imagine many of you feel that way. So the very first step in crossing this divide was to listen, and we did it with the survey. And I mentioned the first one was launched in 2016, and we've done one every year since, every time revealing really critical insights about our users and the state of the community. We publish all the results, by the way, on go.dev because part of the project's core ethos is to be transparent about as much as we can. And we use what we learned from this survey in just about every product decision that we make. We also expressly invite the community to submit proposals. You know, our view is that Go started as a collaboration between 3 people, and it remains a collaboration today. And by the way, if you want to help define the future of Go, please take a look at the proposal template. Feel free to submit something. We also created a code of conduct, which is actually a lot harder than it sounds, especially when you have to enforce it or evolve it. If there's a community, we understood that we are the ones charged with ensuring that it's healthy, that it's productive, that it's inclusive, that we were the ones who were best positioned to sort of do that, to define the culture of the community. And we knew that that culture was a distinguishing factor in whether other capable developers were going to join this and contribute to it. And what happened is the community thrived. It's really one of the most beautiful things about this project, and I mentioned at the start, it's one of the things that I find most humbling. It's that there are millions of developers who use Go just to build their applications, but even better than that is that there are hundreds of thousands of Gophers around the world who meet up in conferences like this and in other contexts because they love Go. This is from our 2021 survey, where our graphics are a little bit better now. As you can see, we're doing a lot better than we were in 2016. We still have a lot of work to do for sure. I think the work never ends. But we've definitely built a community that feels more welcomed than ever before. 81% of you say you're confident in the long-term direction of the project. 70-some% of you say you feel welcome in the Go community. And we have these tools to continue listening, which is the most important thing we can do to ensure Go's long-term success. So I'll close this chapter by saying that Go became its best self by embracing the community. The next big point was that we also realized we needed to embrace the enterprise. Early adopters and hobbyists first, but there are only so many of those. In order to break into the next level of adoption, we needed to embrace the big enterprise use cases. And this is going to mean more developers, different needs, more applications to consider. So first, why do we even care about growing? Well, it seemed to us that languages are either growing or they're dying. They can't just stay still. And more specifically, growth and therefore survival of a language really depends on the enterprise market. So in this chart, look at Python and Ruby. 10 years ago, they were roughly close to the same place. But Python found a place within the enterprise and Ruby didn't. And on the right side is how it looks today. Python's the #1 most used language. With Go, at some point, the adoption curve flattened. We were saturated with the early adopters and startups, but enterprises didn't take us seriously. And there was resistance on the Go team to solving this by looking towards some corporate segment. To many, Go was still a research project. And there was a lot of resistance to shedding that. There was resistance in the enterprises themselves as well. We kept hearing these stories about small teams going rogue and trying Go out without permission. and then it goes really well, and that causes their VPs to notice, and then it works out. But that required a lot of really determined gophers to go rogue, and we knew that we needed to arm them with the proper sort of embrace of the enterprise in their use cases. So there's a lot we've done to sort of since then to figure this problem out. And one example of that is a thing we call the Enterprise Advisory Board, which I invite all of you who work in companies of some size to come and reach out to us and participate in. This is where we learn about this segment we want to tackle. So feel free to reach out to me about that if you'd like to participate. But there was actually some really obvious things we could do too. So one of those things is this website, which was sort of more of a liability than anything else. And this is what it looked like in 2013. And this is what it looked like in 2019. So this is a different slide. 6 years later, and it's almost exactly the same thing. And this is what it looks like today. So this was relatively easy to fix, and it helps a lot towards establishing credibility, legitimacy. These use cases in particular at the bottom, they really help an enterprise understand how they too can use Go in the way their peers do. Similarly, this is what the Go brand looks like today. The Gopher was loved so much that there was a lot of resistance to creating this sort of branding. But we had to. The idea is this isn't a research project. This is a full-fledged programming language on par with anything else you might consider using in an enterprise. In fact, better. And we're seeing some of the results of this effort bear out today. In our last survey, roughly a quarter, it looks like, of our respondents said they use Go at work in an organization with more than 1,000 people, which is roughly how we define the enterprise. This would have been pretty much unthinkable not long ago. And we keep hearing stories like this. Grassroots, bottom-up adoption across enterprises. Go started as a grassroots effort. Before we could start rewriting critical platforms in Go, we had to first convince our leadership. If we were to go and just say we're going to write this over to Go, we probably wouldn't get permission. So a group of us said, well, let's just build this out and show them how amazing it could potentially be. During our spare time on weekends or when work was slower, we just kind of built it out. So we hear lots of stories like this, and it's kind of awesome, but it's also really educational. We learn from these users, what was needed to make it work for them and their companies, and we apply what we learn in order to make Go really attractive to the enterprise, getting there on their needs, on the enterprise needs. And this learning and directed development leads to the last part of my presentation. It causes Go to evolve. So I said this yesterday during the panel. No is the default answer in Go. So I also said earlier in this presentation that we knew that we couldn't stay put. Other languages are evolving. Go needs to evolve just to keep up. But there are a couple of other things we need to be mindful of too. First, it's the fact that this principle of waiting for good design, right? Practically, this means the default answer is no, which, by the way, might seem to imply that it's a passive activity, but that's not at all the case. Really, what it means is that until we're very confident we have the right approach, we don't accept changes, right? The cost of yes is so high, it means no to everything else. The other thing we have to be mindful of is that broad adoption requires that a language be stable, mature. So there's this tension between evolving, but doing so deliberately and avoiding doing it in such a way so as to introduce instability or a perception of immaturity. So the first of these big evolutionary product moments is the introduction of modules, which the previous presentation did a great job telling you about. And it began in Go 1.11 as an experimental release, and that was back in 2018. Dependency management, whether you use it or not in Go, it's absolutely critical. Every modern language has something like this, and it wasn't until 2018 that Go had our solution for it, and we think it's pretty awesome. Combined with package.go.dev, we think it's better than what other languages do, and we waited until this great solution was ready. And they've been a huge success. I mean, look at this. Today, almost all of you regularly use them. 1 year after their introduction, 89% of respondents said they regularly used Go modules. And then 1 year after that, in 2020, 96% of respondents said they regularly used them. Similarly, because we didn't really understand the needs of external users, we left critical things up to the community, which resulted in all these competing solutions. For example, the IDE. Microsoft owned VS Code and VS Code Go, IntelliJ owned Golang, and there were more than 80 different independent open source tools that were used in the editor alone, all of them out of sync with each other. So we expanded our team's scope, including by taking over this plugin, the VS Code Go plugin, and ensuring that it keeps up with the language. Today, 45% of you use it. And remember, we don't want you all to use it. We just want there to be a diverse community and users and vendors all building Go and making it better. But in order to expose new features in the language, in order to ensure a smooth end-to-end experience, we can't just leave it to chance. We can't leave this important developer touch point just open to third parties. So we evolved, we expanded our scope. Another example is generics. This is probably the first example you thought of when I said evolution. Generics carried so much baggage from other languages and users' experiences with these languages that many feared that if we introduced generics, it wouldn't be Go any longer. It's really early days now, and we still have a lot of learning to do and refining to do, really. But so far, they've been received really well. 26% of you are using them, 14% in production, and 54% of you are open to using them when the need is right, which is exactly how we hope you use them. The last big evolutionary point I'll touch on is security, and this is a little more forward-looking than the others. So some of the biggest challenges today revolve around ensuring not only that the code that you write is secure, but the code in your dependencies and their dependencies is secure as well. And with this web of dependencies relying on other dependencies getting larger and more complicated, there are all these places a bad actor can slide in and stuff in a vulnerability that affects huge swaths of the language ecosystem. Someone at Google once described this to me as standing on the shoulders of giants, but that these giants are drunk and running around. So, in our last survey, the two biggest security challenges that Gophers identified were, first, how do we evaluate third-party libraries to ensure they're secure and free of vulnerabilities? How do we protect ourselves from these drunk giants? And then second, how do we verify that the software we write is free, that we write is free of vulnerabilities? The answer to the first question is vulnerability management. So this is still experimental, but with Go's proposed vulnerability management system, you can check your dependencies against our curated database and get a really cool analysis of your exposure. Other languages have something like this, like I think there's NPM audit, for example, and that'll report just every dependency, transitive or direct, that has a vulnerability in it somewhere, which creates a ton of noise. And that's really hard to sift through, and it means you're just going to ignore it. So what we do instead, and I think we're the only language that does this, is only report back on the vulnerabilities that you invoke, that your code actually causes exposure to. So if there's a vulnerability somewhere in your dependency graph, and there almost always is, we won't flood you with warnings unless it actually affects you. It turns out that these false positives and all the other implementations sort of grind the whole process to a halt. We want to focus on providing valuable, actionable insights. So we'll integrate all this data on package.go.dev, and we'll include it in VS Code Go, and you'll be able to get this sort of insight into your dependencies as early in the coding process as possible. And this is an example of leveraging that strength of having Visual Studio Code Go as part of our scope now, and modules. So The second question, or issue, developers identified was securing their own code. And part of the answer to that question, not the whole one, but part of it, is fuzzing. Fuzzing is a type of automated testing which continuously manipulates inputs to your program to find bugs. And GoFuzzing, which was introduced in Go 1.18, intelligently walks through your code and finds and reports failures. And since it can reach those edge cases which developers usually miss, fuzz testing can be particularly valuable for finding security exploits and vulnerabilities. And we've implemented it in this really cool way, integrating it with a test framework so that tests are automatically created from all the fuzz tests. So if we find some input that caused a bug in your program, you can rest assured that that'll always be tested for going forward. And just like generics, fuzzing is an evolution. Half of you are open to using them when the time is right, and another 20% of you intend to use them soon. So that's it. Now close with just a brief summary of everything we just covered. There were these three distinct product phases to how Go pivoted and became what it is today. First is that we embraced the community. And we did that by creating this process so that we can listen to the community. Second, we embraced the enterprise. We did that by ensuring that things like the website and the logo are professional. We created an advisory board. We sit and we listen to all of the issues that the enterprise needs, and security is one of those that was born from it. I think that's going to be a much bigger issue in the years to come. And we're hearing that now from enterprises. That's something we're ready for. And finally, we've evolved. The modules, the growth of our scope, generics, security stuff. And all of this is how Go became its best self. And that's it. Thank you very much.